Hi there, Miss Barber here. The title of this lesson is Arithmetic Sequences. The learning objectives for this lesson are 1. Be able to recognize and identify parts of an arithmetic sequence, and 2. Be able to compute partial sums of an arithmetic sequence. Roman numeral 1, Arithmetic Sequence. An arithmetic sequence is a sequence of the form a sub 1, comma a sub 1 plus d, comma a sub 1 plus 2 times d, comma a sub 1 plus 3 times d, comma dot dot dot. The number a sub 1 is the first term and d is the common difference of the sequence. The nth term of an arithmetic sequence is given by a sub n equals a sub 1 plus d times n minus 1. For the sequence 1, 4, 7, 10, 13, dot dot dot, find the formula, the first 6 terms, and the 100th term. So, in order to find the formula, we might want to start with the base, which is a sub n equals a sub 1 plus the quantity n minus 1 times d. Now, the first term of the sequence is given. It's 1. It's the first one that appears. D is the difference between the terms. From 1 to 4 is 3. From 4 to 7 is 3. From 7 to 10 is 3. And we see that the common difference is 3. So let's get the formula written. The nth term, which is the formula, is 1 plus n minus 1 times the common difference of 3. Let's clean this up a little bit. A sub n is equal to 1 plus, distributing the 3n minus 3. And we'll combine like terms. A sub n is equal to 1 minus 3 is negative 2, so we'll have 3n minus 2. That's the formula. Now for the first 6 terms, we're given 1, 4, 7, 10, 13. To get the 6th term, you add 3 to it, but let's make sure that the formula works. So the 6th term would be 3 times 6 minus 2. That's 18 minus 2, which is 16. So using the formula and also by increasing the previous term by 3, we get the right term. And then one more thing, we need to find the 100th term. So using the nth term formula, we'll put in 100 for the n. So you get 3 times 100 minus 2. 300 minus 2 is 298. The 12th term is 118 and the 8th term is 146. Find the first term and the nth term. I begin this by expressing our information in sequence notation. That is, I'll write a sub 12 is 118 and a sub 8 is 146. Now I'm going to use the general form of the arithmetic sequence formula. That is a sub n is equal to the first term plus the number of terms minus 1 times d to get 2 equations and 2 unknowns. So I'll start with a sub 12 equals 118. The 12th term is 118. Don't know the first term, so I'll leave that a sub 1. And then n, it's the 12th term minus 1 times d. So we'll get 118 is equal to a sub 1 plus 11 times d. A linear equation with 2 unknowns. Let's do this for the 8th term. The 8th term is equal to 146. We don't know the first term, but we do know that it's the 8th term, so we would put in 8 for the n, minus 1, and then times the common difference. So let's simplify a little bit, and we get 146 is equal to A1 plus 8 minus 1 is 7D. Now we have two equations. That's 118 equals A sub 1 plus 11D, and 146 equals A sub 1 plus 7D. Let's put this in a way that we can easily solve it. So I will write A sub 1 plus 11D equals 118. And let's just subtract the other equation. So we will have minus 81 minus 7D equals minus 146. We can add these two equations. The A sub 1's cancel each other. 11 minus 7 gives us 4D. And then 118 minus 146 is negative 28. And solving for D, that's dividing by 4 on both sides, we get that the common difference is negative 7. Of course, that's not what we were asked to find. We got to find the first term and the formula. So to find the first term, we'll use either of the two asterisked equations to solve for the A sub 1. Let's do the one with the 11. So I will say that 118 is equal to, we want A sub 1 plus 11 times the common difference of negative 7. So 118 equals A sub 1 minus 77. And when we solve for A sub 1, you add 77 to both sides. I'll just switch the order and say A sub 1 is equal to 118 plus 77, which is 195. So we found the first term. Okay, that's done. Now we need to get the equation or the formula for the nth term. So we'll start with the general. A sub n equals, now we can put in 195 for the first term plus n minus 1 times the common difference, which was negative 7. Let's work this out and simplify it a little bit. So we've got 195. Distributing the negative 7, I got negative 7n. Negative and negative makes it a positive 7. So A sub n is equal to 195 plus 7, which would be 202 minus 7n. Roman numeral 2, partial sums of an arithmetic sequence. For the arithmetic sequence, A sub n equals A sub 1 plus the quantity n minus 1 times D, the nth partial sum, written S sub n is equal to the sum of k equals 1 to n of A sub k, which is equal to A sub 1 plus A sub 1 plus D plus A sub 1 plus 2D plus A sub 1 plus 3D plus dot 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 plus A sub 1 plus n minus 1 times D is given by either of the following formulas. The nth partial sum is equal to n over 2 times bracket 2a plus the quantity n minus 1 times D close bracket, or S sub n is equal to n times the quantity A sub 1 plus A sub n divided by 2. Given the partial sum of an arithmetic sequence, find the sum 1 plus 5 plus 9 plus dot 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 plus 401. In order to find the sum, the first thing I'm going to do is find out how many terms we have and adding all of those. So I'll start with a formula for the nth term of an arithmetic sequence, which is A sub n equals A sub 1 plus n minus 1 times D. We have, and again, I don't know the term, but the last term is 401. The first term is given as 1 plus n minus 1. And the d, let's look at the gaps. From 1 to 5 is 4. From 5 to 9 is 4. We're told it's an arithmetic sequence, so the difference is not going to change. And we could do this times 4 for the common difference. Subtract 1 from both sides, and we get 400 is equal to the quantity n minus 1 times 4. Divide by 4 on both sides. We get 100 is equal to n minus 1. Solving for n, I would add 1 to both sides, and we learned that there are 101 terms. Now, let's use one of the two summation formulas for arithmetic sequences. I'm going to use S sub n equals the number of terms added to the first, or multiplied to the sum of the first and the last term, divided by 2. We know that n is 101. We just computed that. The first term of the sequence is given. It's 1. The last term, or the nth term, is 401. And we're going to divide that by 2. So the rest is arithmetic. We're going to have 101 times 402, that's 1 plus 401, divided by 2. So that's 101 times 402 divided by 2 is 201. And the product of 101 times 201 is 20,301. The first term of an arithmetic sequence is a sub 1 equals 12. The common difference is d equals 8. Find the number of terms in the sequence that must be added to get a partial sum of 2,700. So we have a couple of options to choose for the partial sum formula. I'm going to use S sub n equals n divided by 2 times 2 times the first term a sub 1 plus n minus 1 quantity times d. Now let's use the information that we have. So we want the partial sum to be 2,700. Put that in for S sub n. We're solving for the n, and so we'll have 2 times the first term is given as 12. Plus, again, we're solving for n, so we'll have n minus 1, and the common difference is 8. Now, we just need to solve this equation. I'll begin by multiplying through by 2 on both sides. That lets me clear the fraction on the right-hand side of the equation. 2,700 times 2 is 5,400, and that leaves me an n. Times 2 times 12 is 24. Distributing the 8, I'll get plus 8n minus 8. Let's continue. 5,400 equals n times 24 minus 8 is 16 plus 8n. Let's distribute the other n. So we got 5,400 is equal to 16 times n plus 8n squared. Well, what do you know? We have a quadratic equation. Let's set that equal to 0. So I'll rewrite this as 8n squared plus 16n minus 5,400 equals 0. Let's note that 8 is a common factor to all three of the numbers there, and so I'll factor out the 8 and divide it. So 8n squared plus 16n minus 5,400 will simplify to n squared plus 2n minus 675, and that's set equal to 0. The two factors of 675 that will give us, when added or subtracted, a 2 in the middle is 27 and 35. So we will have n plus some value, n minus, and we are going to add. So we're going to have n plus 27 and subtract, so n minus 25. We'll use the zero product property to solve for each of the factors, and we get n equals negative 27 and n equals 25. Two possibilities, but the question said find the number of terms, and so that necessarily throws out the negative, and we get that 25 is the number of terms for this sequence in order to get a partial sum 2700.